So let's start with what you asked. Okay, so how do we handle dynamic array, or how do we handle the change of a pointer? Because basically this is it. How do we change a pointer inside the function? Okay, because we know that if we want to do a function that will be able to change a variable which is not on its stack, we need to pass it by its address. And we know that in order to do that, we need a pointer to manage that address. So eventually that leads to how do we change a pointer which is defined, let's say, in main, and I want to change it in a secondary function. Okay, I want to do that. Okay, so I will take this gradually. I will not just write this is the solution, this is the way you should memorize it. We will take it gradually. And at each step, if you feel that you are close to understand, but you need something extra, an extra detail, just ask, okay? Because at that moment, let's say we can actually understand what's happening. So I will start with the standard IO stream. Again, I'm not using necessarily standard today, so I will write standard each time. So we have this basic program. Okay, I will write in main, and after that we switch to functions, because this is the way we said we will code this semester. We separate all the little things in little functions. So again, just to have a short reminder about static versus dynamic. So we know that when we define a static array, they are written in stone. Okay, once you define them, they will be created, and maybe they will be initialized, but once they are created, you can't change their size because the pointer is constant, because we don't have extra space on this function stack. And we covered this stuff in the previous courses and seminars. So the static array will go like this: int static array. So this is a static array with 5 integers. And we know that by default, they get 0xccc. Okay, don't forget this one. We are in Visual Studio here. So they get 0xcc. And remember, it's in hexa, so each pair of 2 C's for each byte. So actually, each integer here has 0xccccc 8 times. Okay, they get by default. Okay, and if you want to pass the values, again, you have here another static array, and we can do that like this. Okay, equals 10, 20, 30. So now this is a static array of 3 elements. This is with 5. And we know that because we tried and we explained why we will never be able to do that. This will always have 5 elements. This will always have 3. Okay, that's it. You can use those values, but you can't use more than that. You can use less, but not more. And for that, we need dynamic arrays. So we also know that all the arrays, no matter if they are static or dynamic, they are managed by a pointer. So this is a pointer to an integer. This is a pointer to an integer. Remember, in order to handle an array, you need the address of the first element. That's it. And maybe the size. But if you have the address of the first element, you can reach the others because they follow the first one. So this is a pointer to an integer, actually to the first integer from this array of 3 integers. And actually another static array, it's a pointer to this value. Static array, it's a pointer to the first value in this array of 5 integers, which has 0xccc and so on. Now, dynamic arrays are much more precise because you see actually the pointer, it's here. So this will be, let's say, dynamic array. And by default, when you define a pointer, you see in our mind, we say we define a dynamic array, but when you define a pointer, it's just a pointer. So let's say it's just a pointer. There is no array here. Maybe in our head is, but there is no array here. Now, in order to actually highlight the fact that it's just a pointer and that there is no array here. So by just defining this one, you don't have any array. The array is in your imagination. Maybe you would like to have an array here, but it's not yet here. Let's make this pointer null pointer, because by default, it will get 0xccc. So everything gets 0xCCC in Visual Studio. Okay, now how do we create the dynamic array? So you see, when you actually play with the static arrays, that's why it's easier with them, but they are very limited, and it's like a trap. It's actually saying, hey, use me because I'm simple to define. But after that, they are useless if you want to resize them, for example. So when you define a dynamic array again, you just define the pointer. So let's say this is step one. Define the pointer to the first value in the array. You don't have the array yet, but this is the first step. You need to define the pointer to that. Now, the second step will be to create the array. Okay, so if you want an array, you need to create it. So in order to create the array, you need to ask the operating system to give you some memory somewhere in order to have an array with any size that you want. Obviously, RAM is your limit. You can't exceed the random access memory size. So in order to do that, you say this, hey, give me an address in that memory space where I want an array with 5 values. And remember, I always told you, try to avoid the static values, constant values, which are called magic numbers. So if you want to store a variable, to store that number, define a variable. So let's say number of elements. So now I'll say equals 5. And here I will say, instead of new int of 5, I will say new number of elements. And this variable will be useful later because we can change it and so on. Okay, so right now we have the array. And remember, every time you see new, which is the equivalent of malloc, new means in heap. So this will always be in heap. If you see new, it's in heap. If you don't see new, you are on the stack. So where is this pointer in memory? It's on the main stack. Where is its content? Okay, the elements itself, the values, where are they? They are in heap. Okay, so all these variables are on the function stack, on the main stack. This is in heap because I see new here. So new will always give you space in heap. Okay, so we get a 5 integer array in heap, and new will always say this, hey, this is your space. I just created that space for you. This is the address. So what do we need to store the address? You need the pointer, because these are the variables which are able to store an address, and we will use that. Okay, so right now we have the array right now, but before this point, you don't have any array. You just have a pointer, and this is still a pointer to an integer in heap, but we know that after that integer, there are another 4. So totally you have 5 of them there. Now, the next step in order to do something here is to initialize them, because like with statics, when you define an array in heap, you get the default value, and the Microsoft guys, they choose another value. So all values are by default, and we have seen that 0x CD, CD, CD. So instead of having CC in heap, you get CD, CD for each byte. Okay. So in order to do something with the array, you need to initialize it, because otherwise it's useless. Init the values. So we will write this for the integer I equals 0, I less the number of values. You see, again, always define variables instead of writing numbers. It's much more better. I plus plus. And now I will say dynamic array at index I equals, I don't know, I plus 1. Let's say I plus 1. Okay, I plus 1. We don't change I. We just say, hey, the current value of I plus 1. So we will actually initialize them with 1, 2, 3, 4, 5, because there are 5 of them. Okay, so right now we have the array. Now, what can we do with the array? We have initialized it, and now we use it. I don't know, to process other values, to store other values, whatever. We just use it. What can we see about this array? You can see its address. Remember, if you print the pointer, you see the address of the array in heap. So let's see that. Standard, cout, standard, end line. And let's say the array address in heap in heap is, and you just print the name of the variable. So it's like printing a variable. You want to see the value of number of elements. You say the number of elements is, and you say number of elements. In the same way, if you say dynamic array, you see the address of the array. You see the value of the pointer. So we can actually see those values, okay? If you want to print the values, obviously I will say, I will just copy, let's copy this part here. And I will say the values are, okay. Or let's define a function, okay? Why to bother with this? Because we will print the array many times. So let's define a function to print the values. So let's define it here. Void print array. So what do we need in order to print an array? We need the address of the first value. Let's say array address. Okay. And you need the number of elements. So let's write here. Standard. If you don't like the standard approach, you can add here using namespace standard. Okay, so you can do your own example faster than me. But like I said, I will switch between using namespace standard and using the standard prefix just to keep you, let's say, in reality, because I don't want to believe that using namespace standard, it's mandatory. So standard end line. Okay, the values are, and I will say for integer I at 0, I less than number of elements, I plus plus, and we just we print them. Cout array address at index I and the space here. Okay, so this is a function that receives the pointer itself, which means the address of the array, the number of elements, and we just go at that address in memory and just print the values. And remember, we can use this to print a static array, which is on the main stack, or a dynamic array, which is in heap, because this is a pointer to an integer, this is a pointer to an integer. So this is what we expect to get here. The address of the first value in that array and the number of elements. Okay, so let's call print array here. Print array of dynamic array and the number of elements. Great. So if I will run this, build, rebuild, what should be our expectations? Should be to see here an address in memory and to see the values 1, 2, 3, 4, 5, and to see a 0 exit code and no pop-ups with any runtime errors. These are the expectations. So debug, start without debugging. And this is what I got. So the array address is in heap is, okay. Every time we run this program, it will be a different address, which makes sense. We get space dynamic in a dynamic way, and the values are 1, 2, 3, 4, 5. Okay, so let's say these are the steps that we need to go through in order to define any dynamic array of anything. If you need to define a dynamic array of chars, what's different? The type here. This is what's different. And maybe you don't need to carry the number of elements because you have string length. Now, if you want to create a dynamic array of students or products or whatever, what will be different? This will be the type here. And obviously, when you create an array of students, again, when you say, hey, let's create it, you need to pass the student type here. But the logic is the same. You define the pointer, define the number of elements if you need it, you create the space, and after that, you initialize the values, okay? Maybe not all of them at once, but you start initializing the values at some point in order to use the array. Okay, if I will draw the memory of this, because again, in order to understand pointers to pointers, you need to draw, okay? You should do this. And even it looks childish, is not. Believe me, I'm not a child. I want to be, to still be a child, but I can't. If you are actually able to visualize what's really happening in memory, this will help you learn any programming language, because humans are very good at this, to visualize, to imagine. This actually means dreaming, okay? But we are actually dreaming with open eyes. So visualizing what's happening in memory will actually help you understand very complex stuff like callbacks, like asynchronous programming, parallel programming, and so on and so on. So always try to visualize. And the first thing that you should do until you train your brain to do that with open eyes and let's say doing other stuff in the same time, take a piece of paper and draw. Okay. And in this way, you actually help you in order to see complex things, because humans are lousy at seeing complex things at once. You need to take it step by step. Okay. So always do this, even if it looks childish. Just draw, take a piece of paper and draw. And with experience, you don't need to draw it because you will draw it in your head. Okay, so let's draw what we have right now, because you'll understand the pointers to pointers, or at least maybe I will help you to see that. So right now, we have the main stack. Okay, we have the main function. This is it, main. And on the main stack, we just defined some static arrays. So this is the main stack. Let's say this is the first static array, which is fixed size, 5 integers, 5 or 4 bytes. Okay, let's be more 5 bytes. So this is the static array, or whatever what's called. You see, it's fixed. You can't change it. So static array. This is it here. Okay, and after that, after the other static array, we have defined a pointer. So we have defined a pointer here. This is it, dynamic array. You see it? It's just a pointer to an integer. It has no clue that is actually a pointer to many other integers later. So this is our dynamic array here. Okay, so this is the pointer. Now, at this moment, if I ask you what's the size of the pointer, I think everybody will be on the same page and you will say, okay, that's an easy question. I hope I will get this question at the exam because I know the answer. And the answer is 4. And again, this will continue with y. And again, this should be an easy question. And the answer is because we compile for x86-bit processor, which are 32-bit processors. That's why. So I hope this would be an easy question for the exam. For me, it's an easy question, but I hope you will see it in the same way. Okay, so this is dynamic array. So this is just a pointer, and its size, it's 4 bytes because all our programs are built for 32-bit processors. Okay, so what's the value here? Initially here we got null. Remember we said null pointer, which actually means 0 or not. It's the same. But later we did this, we created the array. So we did this number of elements, and yeah, there is a number of elements here. Let's also draw this variable here. So let's draw it here, number of elements. Okay, so this is a number of elements, and our current value now is 5, and this is an integer, so 4 bytes. Okay, so this is number of elements. So we have that instruction here. Okay, when we said let's create the dynamic array. So we had this dynamic array equals. So what's the effect of that? We get some space somewhere else. So not here. This is the main stack. You will never get space here at runtime. And this goes for main or any other function. You will never get extra space here. So we actually get some space in a very special area of RAM, which is called heap. Okay, so heap. So right now, the effect of that instruction, I will just write the instruction here at the border. Okay, new int of number of elements, and we know that number of elements is 5. So right now we get here in heap a space, a continuous space of 5 multiplied with 4 bytes because it's int. Okay, so that's why I know how much. And here by default you get that 0xcd, 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 cd, and so on and so on. And what's important for us is that new creates this space in heap and will always return to us the address of this space. So let's say the address here is AA. Okay, so this is the address. Now, where do we store this value? Always check what's to the left of equals, because you have something equals new. So this address will go into that variable. And I bet that that variable is a pointer, because these are the only variables that can store addresses here. So that value will go here. This is the pointer, AA. And this is the effect of that instruction, dynamic array equals AA. And we might say now, we know this, that this pointer now points here, which means every time after this moment, I will use this name, dynamic array, I will actually refer to this address, AA, which means that array which is there in heap. Okay, so this is the effect of what we have right now. We have this image in memory. This is your pointer, this is the number values. And after that, using the dynamic array, we go through these values using its start address, and we set here 1, 2, 3, 4, 5. Okay, so AA is the value that you see here. When I run the program, is this value here. Okay, so here I'm using much more simpler addresses just to help you follow the example, because again, this will change every time we run it. Okay, so this is what we have right now in memory. The static array will be always here. You can't resize it. You can't use more than that, because we have seen we will overwrite other variables and so on and so on. So how do we resize this one? Because at some point we may say, hey, 5 is not enough. I need bigger one. And we also talked about the fact that, as with static arrays, never try to reuse the extra space after you. Don't do that. Sometimes it will work, sometimes it will crash. But generally, this is wrong by definition. Why? Because you see, when you ask heap, hey, give me 20 bytes, this is the space from this point to this point. Everything else is not yours. And everything else could be for another process, for another application. You don't know what will happen with this space in the future. So generally, we don't use if it's something here, we don't use it as extra. The safest way, and that was the conclusion of that discussion, is to create a new array with a new size. So how do we resize it? And again, I will do this in main. And after that, once we are all clear with the effect of that, and everybody will say, okay, so it's clear. We know that, how to resize an array. We take the same logic and we implement it in a function, because that's the moment where you may say, so how do I pass that pointer? What means a pointer to another pointer? So let's clarify what we will do. And we will test it here in main. So how do we resize them? Okay, so let's say we have seen it. Let's resize it. Resize the dynamic array. I will never try to resize a static array, because by definition you can't. Okay, so that's why we don't use static arrays, or use them, but less frequently. So resize the dynamic array. So in order to resize it, remember, you can't use what's here. So by definition, we do this. We ask for more space, and we use that extra space. So in order to resize a dynamic array, actually means to change the address which is now in dynamic array, in this pointer, with an address where you have more space. So actually resizing the dynamic array is actually this thing. Dynamic array equals new int, and let's say 20. So right now, or 10. So right now I want 10 values, not 5. 5 there are not enough. So this is resizing. You are actually changing the previous address from here with a new address where you have now 10 integers. Earlier you had 5. So what's the effect of this new line? Let's see. Because resizing an array sometimes means two different things. So let's understand why. So the effect of that instruction at this point is this. We ask heap to create us a new space. So we have here new int of 10. So now the operating system will say, okay, here it is. You ask for more, here it is. So now we get 10 multiply with 4 bytes, which means 40 bytes. This is what we get. And like earlier, this space has an address. Everything has an address in memory, BB. And where do we get this value? So this value, again, if you go to the main program, just check the pointer, which is to the left of equals, dynamic array. So the new address BB will be stored in the pointer called dynamic array, which means we will override the value from here. So now you have BB here instead of AA. And now you say this pointer is pointing here. What happened with the previous link? It's lost. So right now, when you change the address from a pointer, you lose the previous address because you can't store two values here. You can't say, hey, let's keep AA and BB. No, it's either of those two. So when we do this, BB, when we overwrite AA, here, when you visualize this, we have a new link to this new array here in space, 10 integers at the BB address. But now we just lost the link to the previous array of 5 integers, which was at AA. Because here you see in main, there is no other variable which will say to you, hey, remember the initial array? This is its address. You lose it. Now, what will happen with this array here? So this is what we will talk tomorrow, because we will talk about copy constructors and destructors. So when you leave something in heap and you don't have any way to reach it again, it's like you don't have any other pointer with the original address. This is left in heap, and this will be called a memory leak, which is not a good thing, because it's like your RAM will leak. You will have less and less memory leak, but we will cover this in detail tomorrow. So when this will happen, when this is left in heap. Okay, so this is an issue. And in order to prevent that memory leak, we need to delete the array, this array, before you change the address. And always remember that when you change the address from a pointer, just ask yourself what's happening with the previous space. Do you still need that one in memory or not? Okay, this is one question. Yeah.
It's the same thing if we say dynamic array equals new int of 10 elements, or if we change the no elements variable.
So let's say resize. I got the question. Just validate me. So that will be resize version 1. And instead of allocating, doing dynamic array equals new int, you just say this, number of elements equals 10, right?
Yes.
Okay.
Or we modify the value in create the array.
Yeah, but if you go back here, that's a different story. This means you created it already with 10. So let's keep this one. So let's suppose we have created it initially with 5. And later in the program, we need 10, okay? So is this the same thing with number of elements equal 10? So let's go to the image. If you just change the number of elements, so if you just go here in memory and you say, hey, instead of 5 here, let's write 10. Do we get here extra space? When you change the variable here from 5 to 10, something will happen here? What do you think?
Because we didn't allocate this.
So you're just, this is like VB equals 10 or VB equals 20. Changing an integer variable value has any effect on heap? No. So you just change the value. And you see, in our mind, we may think that by changing the number of elements, we are actually extending the size of this array, but that will never happen. So we will never change the variable here from 5 to 10 without actually doing something here. And remember, once you get this space, there is no guarantee that here you have extra space for another 5 integers. Maybe this is Zoom recording, which is eating up a lot of my memory. And maybe this is Zoom. and the operating system is, okay, I found 20 bytes here. This is it. This is all I got. And here is Zoom, okay, or any other application which is running on your machine right now. So that's why never trust the space here, okay? Never try to use it, because sometimes your program will work and you will say, hey, you see, you tricked us. You said we could, but I have a program which works. Yeah. Does that work on any machine all the time? Because sometimes it will crash. Sometimes you will not have this space, okay? So that's why don't change just the size of the variable which manages the size of the array. If you want to be sure that your program will always work on any machine, no matter how available RAM is, always create a new array, okay, with a new size. So that was a very good question, because now again we realize that. So resize version 1, which means not enough. Your array has the same size in heap, okay? By changing that value, you don't change the actual size of the array. It still has 20 bytes or whatever its size was. Okay, so we don't do this. So let's go back. We resize the dynamic array by creating a new one, and this is the only way. So we create this one here. Now, my question to you is, you have seen what will happen if you just change the address. You lose the previous one. So let's ignore the memory leaks. Okay, so yeah, 20 bytes, who cares? I have 8 gigabytes of RAM, 20 bytes, they will go unnoticed. So just ignore this until tomorrow. Now, the real question is not about the memory leak itself. The real question is, when you resize the array, do you need the previous values? Do you need this one here? This is actually the question. So when you resize it, do you want to create a new one starting with empty values, or do you want to, because resize means increase the size and keep the values, right? If you search for the definition of resize, means keep what you have and extend the size of that, okay? This is what I understand when you say resize. So the real question when you resize is always this: do you want to keep the previous values? So always ask this before resizing. Resizing, ask if you still need the previous values. So do you need the previous values? Let's start with a no. So if you don't, no. Then if you don't need the previous values, you can delete the previous array. So right before creating a new one and getting the address of the new one, you can delete the previous one. Delete dynamic array. So by doing this instruction, and delete is like free from C, it's the opposite of malloc. So delete is the opposite of new. When you do the delete dynamic array, you're actually saying to the operating system, hey, thank you, I don't need these 20 bytes anymore, just delete them. And they will be deleted, okay? They will be released, so other programs, including us, we can reuse later this space here. And this is the fair thing to do. Okay, so generally we delete that. Okay, now let's go to the yes answer. Maybe your answer is yes, I need those values. So let's cover the yes. So if the answer is yes, then before losing the address to the previous array, okay, because that will be the effect of that instruction, dynamic array equals new array of the 10. Before losing this address and creating this new array, you need to keep a link, you need to keep this green link alive. Because in order to copy the values from here, 1, 2, 3, 4, 5 here, you need the green link, okay? You need this address, AA somewhere. Because by using that green link, you can actually copy the values from there here. So in order to do that, this is one way. You can do it differently. We create a copy. So the new array will be created as a copy. So let's say this goes for no. This will be the approach for no. You just delete the dynamic array and you just resize it. This will be the use case when you don't need the previous values. Now for yes, I want to save the green link. So I will define a new pointer and it will be the same as the initial one. Let's say new array. And I will store the new address here in the new pointer. So new int of, let's say 10. So what's the effect of this line in our image? Now we have a new pointer, which is called new array, which is here on the function stack. Okay, so I can actually, we don't lose this anymore. Okay, the previous pointer is still pointing there. Okay, so here you still have AA. Okay, we didn't change that. We still have AA here, which means we still have the green link. Okay, and now instead of having the same pointer pointing to a new address, because that will not happen, let me delete this one. Okay, now we have a new pointer. Okay, so let's draw the new pointer here. So this is new array. It's another pointer. Okay, so this is new array. And the new array now takes the value which is returned by the new instruction, new int of 10, which means takes BB. Okay, so BB. And now this pointer is pointing to the new array, like here. And you see, we still have a pointer which is pointing to the old one. So the initial pointer is still pointing to the array with 5 integers. And now the new pointer is pointing to the new one. And because we have links to the old one and the new one, now we can do this copy here. So let's do that copy. Okay, so let's say here, create the new array. Okay, copy values from the previous one. So how do we do that? For integer I at 0, I less than number of elements, I plus plus, and now we do this. New array of index I equals dynamic array at index I. So this for loop will actually copy 1, 2, 3, 4, 5 from the previous array into the new array. Now the new array has 10 values. The last 5 values will have 0xcd cd, but the first 5 will have the previous values 1, 2, 3, 4, 5, 6. So the effect of this loop is here. You now have here 1, 2, 3, 4, 5, and the others are 0xcd, 0xcd, and so on. So we will initialize them later. Okay, so this is what I should get right now. Okay, this is the image. So what was the idea? In the end, to make the dynamic array, which is the pointer, to point to the new resized array. So this is the moment when we don't actually need the old one because we got the values from it. So this is a good moment to delete this one and to make this pointer also point to the new array, because that was our initial objective, to have a new array with a bigger size. And now I don't care if I lose this. So how do we do this process? The first thing I should do is to delete this one. So this is step 1. And the second step will be to initialize the pointer with the new address. So let's do step 1. So now we delete the previous. We got the values from there. So we delete it. And how do we copy? How do we make this link? So how do we make the dynamic pointer here to actually pinpoint not to AA, but to the BB address? So at this moment, which is the variable from main stack which has the address of the new array? Where do we have the BB address stored? What's the variable name which is stores that value for us?
New array.
New array. So new array, it's a pointer to an integer. Dynamic array, it's a pointer to an integer, right? Which means they have the same type. So what should I write in order to copy the value from new array into dynamic array? To copy BB here over the previous value. So who is dictating to me? So what's the instruction that will copy a value from a variable to another variable? Copy the address of the new array. What should I write? Just say it and I will write it. How do you copy a value from one variable to another variable? If you have VB1 and VB2, what would you write in order to copy the value from VB2 into VB1?
VB1 equals VB2.
Okay, because they have the same type, right? There are two integers. So if I have two variables with the same type, just ignore that there are pointers. One is called new array and the other one is called dynamic array. How do I copy the value from new array into dynamic array? They are variables. So
Dynamic array equals new array.
exactly, equals new array. So right now, we just copied the value from new array into dynamic array. So it's like copy this value from here. So now you have BB, which means now we have the link towards the new array. So let's print this. Let me show you that we just did that. So I'll copy this line from here. I want to show you the new address. This will be the proof that now dynamic array points to BB. So the new array address in heap is, and again, let's print the array. Print array, dynamic array, and number of values. Now, a number of elements. This is a good moment to update the number of elements. Because you see right now, dynamic array is pointing to the array with 10 integers. So right now, we need to update the number of elements. Because right now we are actually pointing to an array with 10 integers. Okay, so yeah, updating the number of elements is mandatory, but after you actually change also the pointer address equals 10. So let's run this. Build, rebuild. Okay, debug start without debugging. 1 second. Okay, debug start without debugging, and let's see what we see. So the new array address in heap is this one. You see it's different than the previous one. So initially when the program started, this was the address of the array with 5 integers, the initial one. After that, we have created a new one with 10 integers. And now this is our new address, which is different than the first one, which is great because this is BB, this is AA. And the values are, you see, 1, 2, 3, 4, 5. So we save the previous values, 1, 2, 3, 4, 5, and the other 5, they have 0x CD, CD, which is again something like -8 something billions and so on. Okay, so right now we have resized the dynamic array, let's say, by doing this process of going through creating a new one and so on. Okay, so this is the, let's say, the main story of resizing an array, and this applies to any arrays, char arrays, student arrays, whatever. Now let's go to version 2.0. Let's make a function which will actually do this, because like I said, class is all about functions, and generally we will not code into main. So let's say today it's an exception. We said we will not do that, but we did that just to be able to follow the algorithm and to understand what's happening. Now let's make all this story a function. So let's go up here. And let's try to create a function which will do exactly what we did in main. So let's start with the easy part, the name of the function. Let's call it resize array. Now, in order to resize an array, what's the information that we need? What do you need as input to resize an array, an existing array? What do you need? Just tell me the values that you would need to do that, to resize the array. It's obviously we don't need nothing, right? Because you need something to resize the array. So what that would be to resize?
The initial array.
The initial array. And when we say the initial array, we actually mean the address of it, okay?
Yes, yes.
Exactly. So I need the initial array. Okay, great. What else?
The array in which we want to change the size in?
No, we will resize this one. So you get the array and I will resize it. So I don't need another array. We will create that one.
We need the initial size of the array.
Exactly. The number of elements, right? Number of elements. And so you have the address of the initial array. You have the number of elements there. In order to resize, you need what?
The new size.
The new size. Exactly. New size. New size. New size. Okay. So this is what we need. Right? We have the address of the pointer. So the idea is to change this because you see in the end, after we have resized the dynamic array, we still play with the dynamic array. We don't just create other pointers. We still play with dynamic array. So I still want to keep my pointer variable. So let's suppose here we want to change initial array. And again, we will change number of elements, and this is just for input. So in this case, I will write this function. So it will return nothing because my goal is to make this function change the initial array pointer and change also the number of elements. So after we call resize array here in main, we want to see the same effect. Let's suppose right now dynamic array will have 10 elements. We will call here resize, and I will want to make dynamic array with 20 elements. So I want that the new the variable number elements after the function will have 20 as a value. The dynamic array will have 20 values and so on. So this is my goal. So I just defined the function. So let's say this is the naive approach. We will see if that works and what do we need to change. So we have this function. We just encapsulated the values that we want to receive here. So we know how to resize an array. Yes, we know. We just did that in main. Okay, we know the algorithm. So what do we need to do in order to resize the initial array? So it's the same steps. I will not write the comments. We will define a new pointer temp equals new int of new size. Okay, so I will define this one. This is the new array there. I will copy the values. Let's say we go for the yes answer. Do you want to keep the previous values? Yes. So int I at 0, I less than number of elements. Okay, I plus plus. And now I will say temp index I equals with initial array at index I. Okay, so we copied the values. Now we don't need the previous array anymore. So what we did, delete initial array. Okay, and after that we said initial array equals temp. So I want to get the address of the new array with the new size, and number of elements equals new size. So you see, this is actually what we did earlier in main. If you just ignored all the comments, these are the steps that we followed earlier in order to create a new array with a new size. So once you know the algorithm, the only thing, let's say, that you need to decide is the signature of a function. Okay, you need to decide what you need to receive in this function. Okay, so let's test it. Let's see if that works. Okay, let's see if this function works. So remember, the goal is to actually change initial array to have a bigger size and to still have the previous values. This is the goal of this function. So I will go here in main, and I will say resize array of what? Dynamic array, number of elements, and the new size, let's write 20. And after this function, if I copy paste the same lines here, the new, let's say, resized array address in heap is, so here we should see a different address from the one here, because now we have a bigger one with 20 integers. And here we should see 1, 2, 3, 4, 5, and another 15 integers with 0xcd. So this is our these are our expectations after we call resize array, right? This is what we expect to see. So let's see. Build, rebuild. Okay, no compiler errors. Start without debugging. Okay, and we see this. So initially our array pointer has this address. After that, we have resized it in main. We got a different address. It's now, it has been resized to 10 integers. And now check this line. The new resized array address in heap is, yeah, but this is identical with this one. Okay, so this is our first clue. And if you check this line, you will see that here we are missing 1, 2, 3, 4, 5. So what happened? We lost them. And if you count how many values you have here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the last one, continues here. We don't have 20 values. We still have 10. And exit code is 0. So this is a case where the real actual problems of programming are, because you see, you have no clue. If you run this in debugger, you'll have the same output. So exit code is 0, which means the program did what we said to do, but the values are wrong. We don't have a new address here. We just lost 1, 2, 3, 4, 5. And where is our 20 integer array? Because I still see 10 values here. So these are actually the real issues. Okay, compiler errors are easy. Runtime errors, okay, you can get help. The debugger will help you. But now no one is helping you. So you need to follow the execution and try to figure it out where you did the mistake. So how do we find the mistake? Why the function didn't work? Because we did the algorithm in main and it worked. This is the proof. We were actually able to resize the array from 5 to 10. So the algorithm is the same. Okay, so it works. Now, why is not working when we do it in a function? So let's draw the memory. So we call resize array. Let's go back to the drawing board. When we call that function, another stack is created, because remember, when a function is executed, you get a function stack. So this is the resize array stack. Let's write it here. Okay, resize array stack. This is it. Now, what do you have on the function stack? Remember, you have all the local variables, including the one in the arguments list. So you have these variables and you have this variable and maybe I. So everything you define here and everything you receive here, those are your function variables. So what do we have? We receive a pointer to an array, the initial array pointer. This is it. So this is the at initial. Okay. After that, we have the number of elements. Okay, number. And this is the new size. Okay, new size. And after that, we define a temp here. So this is the temp that we define here. So this is another pointer at temp. Okay, so if you follow the algorithm, I will just follow it on the drawing. So what do? We create a new array with the new size. We copy the values from there. We delete the previous array. We copy the address in the initial array pointer and we change the number of elements. So what will be this effect here? So we create a new array with size 20. Let's create it here. It's a bigger than the previous one. So right now we have 20 multiplied with 4 bytes. So now we have 80 bytes. The address from here, let's say CC, goes where? If you check the instruction, is temp equals new int of new size. So this address goes here, CC. Now this pointer points here. We copied the previous values. Okay, how do we get the previous values? Remember that this function receives the initial array pointer value and number of elements. And this is the proof. You see, when we call the function, we say, this is the value of our existing array, the address of it. This is our current number of elements, and this is 20. So all these values go here in the function resize array stack function when we call it. So let's write the values. New size will be 20, because this is what we pass. Number of elements will take this value from here. Okay, so this goes here, 10, the value. And initial takes the value of our dynamic array pointer, and is the same as we did before. So what value do we get here? BB. You take the value from this pointer, because this is what we passed as value when we call the function. You see, resize array of dynamic array. So the value of the first argument goes into our local variable called initial array. Okay, so right now you have here BB, which means this pointer here, initial, is actually pointing here. Okay, at BB. So right now the function using the initial array address and using temp will copy this one from here. So this is copied here. This is copied here. That's the for loop in resize. So right now we have here 1, 2, 3, 4, 5, and everything else will be CD, CD, CD. Okay, so at this point, we are in the function here. We just did the for. Now we do this, delete initial array. Okay, so which array is deleted? We check the address here in initial, it's BB. So which is the array which will be deleted? This one, we don't need it. So that's the effect of the delete. And after that, we do what? Initial array equals temp. So again, two variables with the same type, we just copy the value from one to another. So what value I will write here? Initial equals temp. So what's the address I will write here? What's the value in temp? So what do I write here? A, B, B, what do I write? Anyone? If there are no answers, ask me.
It's CC.
It's CC. Okay, so if you don't have an answer, just give me a clue. Ask me. Ask me what's not clear. Okay, why? What's preventing you to see the response? Okay, so here now we have CC. Okay, so now this pointer points to the new array here. Okay, which this is what we wanted, right? This is what we wrote here. Initial array equals temp. And now number of elements equals new size. So number of elements equals new size, which means this here is replaced by 20. We just copy the value from here. Okay. And this is the function. You see, it has created a new array with 20 elements. It has deleted the previous one. Okay, we have the new resized array. What will happen with this function when it terminates? With its stack, it's destroyed. We lose this. And we go back to main. Now, when we go back to main, what's the value that we have here in number of elements? It's 20 or it's 10? When we go back to main and we want to use this variable, what's the value here? It's 20 or 10?
10, I guess.
It's 10, right? Because you see, everything we draw here, we just change values here. We didn't touch this one here. So it's still 10. And what's the value in dynamic array in the pointer right now? When we go back to main. So what's the value here? Is CC
BB.
or BB? It's still BB, because again, everything we did in that function has changed the local variables. Okay, the function changed the values here in its own local variables. Dynamic array from main, it's still BB. And this is quite interesting because this pointer here is still believes that in memory at BB, there is the array, but there is no array there. Why there is no array there? We just deleted it from the function here. Remember, we did the delete. So this pointer has, no one will notify it. So in C and C++, no one will say to this pointer, hey, just look at this. You don't have that array there. Another function has deleted that space for you. So when you have pointers which are pointing to addresses in memory, which they don't exist because you deleted them, that's a dangling pointer. Okay, so this is the definition of a dangling pointer. It's a pointer which points to an address that was valid at some point, but now at that address there is nothing because you just deleted that space from another location. And that's a dangling pointer. It's a pointer which will tell you an address which is not valid. So now we try to print this array here. We are actually trying to print what's in heap at BB, actually 10 values. And you have seen the effect. Now, maybe because this is Monday, who knows? Maybe if I open other applications, it will crash. So sometimes this application will crash. Sometimes you will have a strange exit code and a crash. Sometimes will behave like this. And this is the most painful use case when it didn't crash. And at least we have some clues. So right now, that space in heap kind of is still available. We can read that in heap, but there are no values there because we just deleted them earlier when we said delete. So that's why you don't see 1, 2, 3, 4, 5 anymore, because those have been deleted. And now we see some values in heap at an address which is like the operating system is like saying, okay, I will let you see what's there because maybe that was your previous address, who knows? But normally here, the program should crash because that address is not valid anymore. Okay, so where is the mistake? Because when we coded that in main, everything worked like a charm. Okay, so everything worked. And now we made a function out of that and it's not working anymore. And it's quite actually much more worse. It's deleting the array, is creating a dangling pointer, which is worse. So where is the mistake? If you check this drawing, you will see that the mistake is actually here. You see, what was our goal? Our goal was to actually change this address from here, to change the address from this pointer. That was our goal. And also to change the value here in number of elements. This was another goal. Remember, here we wanted 20 and here we wanted CC. So why this didn't happen? Because remember, and we covered that when we had the course with the pointers and I introduced the interchange function and so on. Remember that by definition, all the functions will play with their own variables. In order to make this function here, the resize array function, to actually change this value here and this value here, what do you need to pass to that function? The address of this variable and the address of this variable. That's why we need pointers. So if you want to make a change of a variable inside a function, you need to pass the address of that variable. Don't pass the value because you may change the value, but you change it inside a local variable of that function. So it will not work when you come back from resize. So let's write the second version of resize array. Okay, and let's learn from our mistakes. The algorithm is okay. That's why it's important to know the algorithm, because the algorithm will work in main, will work in any function. Now, the only issue is how do we make this function to actually change variables from main? So resize array, let's say with pointers. So if I want to do resize array with pointers, it means that we need to change the values that we pass to the function. So remember, in order to change this value from here and to change this value from here, you need to pass the addresses of this red rectangle and this blue rectangle in order for a function to be able to change the value here. So how do we say that? So here, normally we want the address of the official number of elements. We want the address of the variable which is storing the number of elements. So how do we ask for that? Normally, when you need an address, you need a pointer. So a pointer will deliver that value to you. So instead of having int number of elements, I will say here int asterisk address of number of elements. Okay, so this is what we wanted, the address of number of elements. And now this is the tricky part, which your colleagues asked and your colleague asked in the beginning. So how do I pass the address of a pointer? Now, just repeat this 1,000 times in your mind. A pointer, it's a variable. A pointer, it's a variable. A pointer, it's a variable, like VB. So how do you pass the address of a variable? You say this, you define a variable and you say here, address of initial array. You start with the name. Now, you know that every time you need an address, that will be delivered by a pointer. So this is not just any variable, it's a pointer. So I will put the asterisk. So right now I have a pointer which is called address of initial array. And the second question is, what's there in memory? So I will give you the address of that rectangle. What's there? What's the type of the value in that rectangle? So if you go back to the drawing here, what's the type of the pound BB value or pound AA? What's the type of this red rectangle? It's a pointer.
A pointer
To an integer.
to an integer.
Exactly. So the question now is, what's the type of the value there? A pointer to an integer. So now this is how you receive the address of another pointer. You see, always start with the name, just add an asterisk, and now ask the question, what's there? What's the rectangle type? And some of you will say, hey, this is a matrix. Yes or no? Who knows? Yeah, it could be a matrix because a matrix, it's an array of pointers to lines and so on. But who cares? This is a pointer which will manage the address of another pointer. Okay, so don't memorize the number of asterisks. You will mess them up. Always take this gradually. Add an asterisk, define a variable name, and now ask what's there. And now you get the int asterisk asterisk. Okay, but who cares? So how do I rewrite the function? You see, right now, this line is the same. We still want to create a new array with a new size, which is temp. So this doesn't change. And now we want to copy the values. And here initially, we wanted the number of elements. So right now, we don't get the number of elements. We don't get 10, 5, or 20. We get the address where we may find in memory, where we will find in memory that number that we need, 5, 10, 20. So if I will draw now the stack of resize array with pointers. So let's draw the stack of this one. 1 second, just to move a little bit the image here. Okay, up. Okay. So let's define the stack of resize with pointers. So this is resize with pointers. Okay. Now here, what do we get here? We get a pointer, which is called the address of initial array. So this is the address of initial array, it's still a pointer. Who cares? It's a pointer to another pointer. It's still a pointer. It's just a pointer. Address of initial array. After that, we have another, let's draw it with green. This is the address of number of elements. So address of number of elements. Fortunately, this is recorded, so you will not be able to understand. Sometimes I don't. And now I'm using a graphic table, so it's even worse. Okay. And the last one is the new size. This is clear. It's the same, new size. Now, again, here we will have the temp. So temp, it's the same as before at temp. Okay. Now, let's see what values do we get here. So new size will be 20. Okay. Now, what do I write here? You see, initially, I got the value 20. Now, what I will get here? The address of the number of elements value. So where is the number of elements variable? Here it is. You see it? So what's its address? I don't know. Let's write it. Let's imagine that this is in memory at ZZ. So what value should I write here when I will call this function? What do we receive? Do we receive 10 or do we receive ZZ? Here, this is the pointer to this variable here. What do you think? Do we get 10 or ZZ?
I think it's ZZ.
Exactly. So now you have the address of that variable, which means this pointer is actually pointing to this variable here, which is on the main stack. Okay, so this pointer will help us reach this space. Now, if you have the address of something in memory, how do you read the value there? So if you have the ZZ address, how do we write in order to get the value 10? Asterisk of the address. So if you say asterisk of ZZ, this is the equivalent of 10, which is the value there. If you just say ZZ, this is just the address. So that's why we use asterisks with a pointer in order to reach this value, 10. So let's go back to our for loop. So here we want to get the number of elements. We have the address. So how do I write? Asterisk of address of number of elements. Okay. So right now, this is actually equivalent to saying number of elements, but we say it indirectly because we have the address of that. Okay. Here I have temp at index I equals initial array of index I. Okay. So what we wanted to, what was our goal here? To copy these values from here, here. But you see now here, the address of initial array is not either BB or CC. This is the address of the pointer called dynamic array in main. So what's its address? Again, I don't know. Let's invent one. So let's say this is VV. VV. So because this is managing the address of this pointer, what do I write here? VV or BB? When we call resize with pointers and we receive the address of this red rectangle, what value should I write here? BB or VV? Do we get the value of that pointer like BB, or do we get the address of the pointer like VV? And this is a pointer to another pointer. So what do we get here? What should I write here?
The address, VV.
Exactly, the address VV. So right now, we may say that using this pointer, we can actually reach the other pointer. Sorry, yeah, my table, I ran out of the table. Okay, so this is pointing here. Okay, when you have the address of something, how do we get that value from there? So how do I write in order to get this address, BB, which is the address of the dynamic array here? Again, asterisk of the address. VV. So when you write this, this is actually equivalent to say BB, which means tell me what's in RAM at address VV, and this is the value. This is the part of the question. Tell me what's the value, this is the asterisk, at this address. So you will go here at VV in RAM, and you will see that the value in this red rectangle is BB. So VV is the address of the red rectangle. ZZ is the address of the blue rectangle here. And in order to get what's inside here and here, you use the asterisk. So how do I write this using the address of initial array? Because there is no initial array here, but how do I get the initial array? Again, simple. If you want to take the value from a pointer, which is in RAM at that pointer value, you say asterisk pointer, which means address of initial array. So right now you see, and always if you have an index operator here, use the brackets, because in this way you are sure that you will first apply asterisk to address initial array. So now you get the value there, which is BB in our image, and you apply the index to BB. So right now you go back to the array, to the initial array. So how do I delete the initial array? Again, I will replace initial array with asterisk of address of the initial array. How do I change the value there? So how do I write the new value from here, which is CC? How do I write it now here? Here. The same syntax can be used to read and write at that address. So now this value CC will go here. So let's use red. This will change this value here, CC. And you see now we are actually changing the dynamic array pointer here by writing this. What's in RAM at this value at address of initial array equals temp. And how do we change the number of elements? So how do I write here 20 here instead of 10? How do I replace this 10 with 20 here? Again, if you have the address of that rectangle, which is ZZ, asterisk ZZ will help you also write there. So here you will have asterisk of address of number of elements equals new size. Okay, so what's the difference? You see, the algorithm is the same. I didn't change anything. I just replaced some variable names. Now, is this going to work? If you go back to the drawing, to the whiteboard, you see that after we will call resize with pointers, we actually change values here. The dynamic array now will be CC, and the new size, new array size will be 20. So what do you think? It will work? I think yes. And this is what programming means. Generally, you need to visualize what you want to do, and after that to write the code and visualize what the code will do. So in the end, if you have this in your mind, now you will be pretty sure that the function will work. Normally, when we learn how to program, it's kind of different. It's the opposite. You write code and you hope that it will work. This is not going to work in real life. Okay, so we don't write programs and we hope that they will work. Generally, we visualize what they will do, so we know that they will work, and that's why sometimes we will be surprised that we miss something and we have a bug. Okay, so actually everybody does this in their head. Okay, they visualize what they need to do, they write the code accordingly with this image depending on the language. So this image is valid for Java or C#, but the tools are different, the syntax is different. Okay, but in the end it's the same approach. Okay, so let's actually see that this actually works. So let's call this function. I will comment the previous one because it's wrong. So let's say it will not work. Okay. Okay, wrong. It's wrong. Okay, so let's test the new one, resize array with pointers. So I will go here, and instead of saying resize array, I will say resize array with pointers. And now I will say dynamic array, number of elements, and 20. And now the compiler is saying, hey, wait a minute. Here you said to me, based on the function signature, that you will give me the address of an integer. And now you are giving me the integer. And now you say, okay, sorry. So I need to give you the address of number of elements. So how do we get the address of a variable? And or ampersand number of elements. Now here the compiler is saying, hey, you said you will give me the address of this pointer, and you are giving me the pointer. So how do you get the address of anything with the same way, in the same way, ampersand or and. So right now you pass the address of the dynamic array variable and you pass the address of number elements, which means you pass VV and ZZ. This is what the function now will receive. So let's see if this works. So I will just run the program, build solution. Okay, debug start without debugging. I need to run it again. So this is what I'm seeing. So initial address was this one. We changed the array in the main, a new address. We see the values, 10 values. Now, what's this? It's a new address. So the new resize array address in heap is this one. Okay, so it's different than all the previous three. And what's here? 1, 2, 3, 4, 5, the initial values. And if you count, here you have another 15 integers. Exit code 0, which means we are okay. Okay, so we got the initial values, other 15 integers, and the new address. Okay, so in this way, you can actually change any dynamic array. So you apply the same strategy for dynamic arrays of students, of, I don't know, professors, of anything. Or array of chars. Okay, they are still array, dynamic arrays. Okay, now I realized after I sent you the assignment that you got there some questions with C++ references, and I think some of you know already how to use those. Tomorrow at the course, I will take 10-15 minutes to explain to everybody what's the C++ reference and why you can use it, and generally I recommend you to use it because it's actually simplifying this for you. It will just give you the chance to write functions that they work until you really understand pointers. Okay, so let's do it now. Okay, I don't want to keep the secret until tomorrow. So what's the C++ reference and why they have introduced it? So let me show you the reason. So if you compare these two methods, just look at them. They have the same purpose, right? This is the initial resize array. This is a resize array with pointers. Okay. Now, the algorithm is the same. Create a new array, copy the values, delete the previous array, keep the new address, update the number of elements. Okay, same here. The only only thing different is that this is wrong, doesn't work, and this works, because this one receives the address of those variables. Okay, but if you just cross-check this method versus this one, you realize that the only difference which makes everything to work, and that's why we sometimes say that pointers are magic, they are magical. So the only difference from this version to this version, which actually makes the second version to work, is an extra asterisk here. Just look at this. So you say, hey, initially this was a pointer to an integer. Now this is a pointer to an integer because I have an extra asterisk. Everywhere I have an initial array here. Now we have an extra asterisk. You see, it's like a pattern. Here I have just a variable. Now here I have a pointer to a variable. Again, the only difference between these two is an extra asterisk. And again, everywhere you have number of elements. Now it's pointer address of number of elements. So it's like the previous one with an extra asterisk. And that's true. So if you want to change variables inside the function, you need to pass them by their address, which means add an asterisk. And the logic is the same. So when they designed C++, they said, okay, let's simplify this because too many asterisks can be confusing. So in C++, they said, let's allow the developers to write code like this, and the compiler will add the extra asterisks for them. Okay, because you see, managing pointers is just a tool. Our job is to find this solution, not to manage pointers. Pointers are just a tool. The real deal is here. How do you resize the array? So they introduced the reference, which is something we already know, is the ampersand. But if it's used here when you define a function, the compiler will transform any version like this into this version, which means you write like this, but actually you get a function which looks like this. So how I should rewrite this function with references? So void, actually I will do this just to show you the power of references. I will just copy the initial version, which we know it doesn't work because it doesn't change the variables. I will copy it here. And now I will have only one question. Which variables that we receive here by value do we want to change inside the function? So let's think. We want to change the pointer, this pointer, because we want a new address. So let's mark this variable. And we want also to change these variables because we want to update the size. So we mark it here. And that's all. So this is the C++ reference, which means now you ask the compiler when it will compile this code to actually replace here, but you don't need to do that anymore. To replace everywhere you find initial array and everywhere it will find number of elements, to add an extra asterisk. Okay, so this is actually the C++ equivalent of this version, which is actually a C version. So every time you are using an asterisk, this is from C. Okay, and let's name this one resize array with references. And that's it. So until you, let's say, you really will grasp or you get the idea of pointers, you can use this approach, references. You write the function without pointers. Obviously here you need a pointer, but you don't add an extra pointer. You just bother with that. And after that, just ask this 1 million question. Which are the variables that I want to change here inside the function? So I want to change this pointer and I want to change this number of elements. So you add references there. So let's test this one. Let's see if it works. So I will go back in, you see, I don't need to do anything here. Okay, it's like before. So let's call this one here. Let's see if this one works. So I will say here, resize array with references. What do you want to pass? Again, you don't need to bother with pointers. What do you want to pass? The dynamic array. What else? Number of elements and the new size. Okay, so we call the function as before. Okay, so you don't need to pass ampersand here and so on, because the compiler will do that for us. So if I will run this, okay, debug start without debugging. And we will have the same results. We get a different address. It's different than this one, and it's different than this one. You have your array 1, 2, 3, 4, 5, and you have the other 15 integers. Okay, so this is what they did in C++. This is the reference they introduced in order to help us manage pointers in a much more simpler way without just adding asterisks after asterisks and so on. Now, during this semester, both versions are allowed. You can use any of these two versions in order to write your own functions. Okay, so if you understood pointers and you still like pointers, you can use this approach. Or if you want to sometimes, I don't know, to go for references or just use only references, again, you can go for this approach. So both versions are okay. The idea is just to know how to use them properly to make your program work. Okay, so I hope we clarified again some things about pointers. You will need this understanding because in the second semester you do data structures in C. So there you need you still need to understand pointers at this level. Okay, and if you code at some time in your professional career, which means a lot of years, so you will have like at least 40 years in front of you of coding if you want to follow this path. At some point you will go back to C. So in C, this is the only way to do it. Okay, so if you understand now pointers, and after that you are okay either with this approach or with this approach, you solve a lot of future let's say issues.